Okay, it's 11. I'm going to give it about another 30 seconds. I won't be speaking long. I know they want to hear you, not me. Okay. Normally we have the little, I'm getting ready to record now, and I'll start the presentation, and it'll say, presentation starting now. But it's already started, so good morning or good afternoon or whatever it is, wherever you're at. This is the March webinar, our March meeting for DBA Fundamentals. Today we're going to have Guy Glanster presenting a presentation called How to Use Parameters Like a Pro and Boost Performance. I've got to go over a couple of things first. First of all, PASS has tons of virtual chapters. In fact, from this screen you can see all sorts of them. Not all languages, but a lot of different languages, a lot of different countries, and a lot of different topics. Ours happens to be sort of a general for people starting out and all the way up to senior DBAs, because we kind of go across a range of things. But you can see there's big data, book readers, data science, the DBA chapter. They do higher level stuff, security. Sign up for one. Sign up for all of them. Here are some chapter meetings coming up. Women in Technology is going to be doing gender inequality in tech and leadership. That'll be tomorrow. We'll be doing another one in our DBA Fundamentals Down Under, the transaction log and how it affects HADR with Edmund Sarmiento. Our Down Under chapter pretty well does a little bit higher level stuff than we do. And they're also, it says March 8th. It may be, yeah, that it would be March 8th at 9:30 to 10:30 Central Daylight Time. But you kind of have to look for it. So check that one out. Then HADR's got a session on March the 8th also. HADR features in 2016 for Windows and SQL Server. Big Data is doing one introducing USQL and scaling USQL and doing SQL in USQL. We found out about that at our local PASS chapter here in Nashville. That's the other thing. There's probably local chapters you can go and meet people in your local area, so you can check that out at sqlpass.org. In April, we'll be doing a session called Kicking and Screaming, Replacing Profiler with Extended Events by Erin Stellato. She's always a great speaker. And the same month, the Down Under chapter will be doing Understanding SQL Server Backup and Restore with Tim Radney. Another SQL skills speaker. He's always great. In May, Jess Borland will be doing Beyond CX Packet, Understanding Weight Statistics. That's very important in performance tuning, as you'll find out. Weight statistics are one of the key things that you can use to determine what's going on in the system. And then in August, we'll have High Availability and Disaster Recovery 101 with Glenn Berry. Our sponsor, SQL Sentry, is having a contest in April. I don't know the exact details of the contest, but I know the general idea is that they'll be giving away either a professional version of Plan Explorer or other things. If you send them in, you can download the free copy of Plan Explorer, and if you'll the hairiest execution plan. The worst query, because I know you've got users out there that can really do some crazy, unbelievable stuff. That's what they want. And the version of Plan Explorer that you download allows you to anonymize all of your information in the query, so you can successfully take it and send it someplace without worrying about divulging any company information. So that's a great thing. If you want to take a picture of this, go up to the right-hand side of your screen, and you can click on a picture and go to any of these links, and you can download a trial copy. It's totally free. They don't even, like they said, they don't even ask for your email to get a free Plan Explorer. If you're doing performance tuning, I advise you to try this out. It's fantastic. There's all sorts of volunteering opportunities with PASS. If you want to go to volunteer.sqlpass.org, you can get tons of opportunities local. You can get tons of opportunities with local SQL Saturdays. We just had ours in Nashville in January, but there's one going on all the time. You can go to sqlsaturday.com, and it will there will be tons of information. You can see the one closest to you. And if you want to join PASS, everybody in this session has already joined PASS, but if you want to send these links to some people that you're interested in or that you know, you can send them to sqlpass.org, and they can sign up and join all these other chapters. Okay. Today we have Guy Glanster. He's a SQL Server MVP, and he's the leader of the Israeli PASS chapter and also the CEO of Madeira. His career has been focused on SQL Server for the past 18 years, and he's performed various database roles as either a DBA, an external consultant, or an instructor. He's involved in many activities in the SQL Server community, and he occasionally speaks at community events such as TechEd, PASS Summit, SQL Rally, SQL Bits, and other user groups around the world. He also co-hosts the SQL Server radio show. Okay, I'm going to turn it over to you now. Guy, let me pass the presentation back, and then I'm going to mute myself until there's a group of questions and you ask me for them.
Thank you, Steve. Can you see my screen now? Steve?
I'm sorry. Yes, looks good. I forgot I muted myself already.
Okay, great. Thank you. Thank you very much. I'm very happy to be here. I'm actually honored to speak in this very successful virtual chapter. My name is Guy, and I'm going to talk to you today about a topic that is very close to my heart. I've done this many, many times throughout my career, and it's called how to use parameters like a pro, and of course, how we can boost performance by doing it the right way. A few words about me. So my name is Guy. I'm the CEO of Madeira Data Solutions. Our company provides data solutions and services, either infrastructure or development or BI, cloud solutions as well. I'm a data platform MVP. I've been doing SQL Server stuff for almost 20 years now. You can see here my email and Twitter account. Feel free to keep in touch, of course. My blog, I will publish all the session materials, the presentation, and the scripts I'm going to show you here on my blog, probably tomorrow. And I'm also co-host the SQL Server Radio podcast, which turned out to be very successful. We've got lots of listeners, so if you don't know SQL Server Radio, go to sqlserverradio.com. Me and Matan Jungman, we just talk a lot about SQL Server stuff, professional stuff, events in the community. We have some guests once in a while, so check it out. So much about me. And before we start, let's begin with a story. Now, I presented this session in the last PASS Summit 2015, and I presented a video at this point, but since this is a webinar, we have some issues with the audio, so I'm just going to tell you the story. And the story goes like this. I get a phone call from a client. It's usually in the middle of the night, unfortunately, and the client tells me that there's a performance issue and it's critical and it's urgent, and I say, what happened? So he says there's a store procedure, and this procedure used to run for like 50 milliseconds each time consistently, and starting in some point in time, like 2 hours ago, since then the same procedure has started to run for more than 5 seconds each time. and it's consistent. It used to run 50 milliseconds, now it's more than 5 seconds. And then, of course, I asked the client, so what have you done? What has changed in the system? Have you removed any indexes, added any indexes, changed anything in the schema of the tables involved, changed the code maybe? Maybe you loaded a large amount of data in one time. You restarted the server. Something must have changed that caused this behavior. And the client, of course, says, no, we haven't done anything. So we have a little argument, and then at some point I say, okay, let me connect and see what's going on. So this is the story, and we're going to go through, it has to do with parameters, right? Of course, we're going to go through this session, and at the end of the session, we're going to go back to the story, and I'm going to show you what happened there and how we solved the problem. So I would like to answer a few questions during this session. What is parameterization in SQL Server? Why is it so important? And my message here is that parameterization is very important. I'm going to show you why, when, in what circumstances does it become problematic, and how can we deal with it and overcome the issues, the problems that go with it. So let me show you a simple query as an example. And when I talk about parameters, I talk about this, of course, this value over here. So this value can be a constant value, like this value, 17. It can be another constant value, and it can be a parameter that represents a value, okay, such as this one. And for the sake of this presentation, I'm going to use a very simple case study. I call it the customers by country case study. And it's a simple query. It looks like this. Okay, so we have the customers table, and I'm querying the customers table, and I want to see all the customers from a specific country. We have a country column, which has 2 character codes of countries, and for this example, I would like to see all the customers from Israel, which is where I'm based. This query is going to help me demonstrate all the issues around parameters during this session, and it's time for a short demo. Okay, so here's the query. I hope you can see it well. Okay, so in this case we have 76 Israeli customers. I would also like to show you the execution plan. We're going to use it later. So I get an index SIC and a key lookup. I have an index on the country column. Of course, everything looks fine. This is the case study. Okay, so we're going to get back to this later. Let's move on with the presentation. So first, I would like to talk about plan caching. Okay, before we dive into parameters, plan caching is a very important topic. SQL Server has an area in cache called the plan cache, where it stores execution plans of queries. And the idea is to be able to reuse execution plans, because the cost of parsing and optimizing and compiling a plan for a query is quite expensive. And if you have to do it many, many times, again and again, it's going to affect performance dramatically. So we would like to be able to reuse a plan if we encounter the exact same query that already has a plan in cache. We would like to reuse that plan. Now, when a new query comes along, the query processor has to go through a few phases. It looks for this query. It looks in the cache, in the plan cache, whether there is already a plan for that query, and it does that by calculating a hash value over the query text. So each time a query comes along, there's a hash function. SQL Server calculates a hash value for the text of the query, and when a plan is generated, it is put in the plan cache alongside together with the hash value. So when a new query comes along, SQL Server calculates the hash value, compares it with the current execution plans and their hash values, and checks whether this hash value already exists. If it doesn't, it goes on and compiles, generates a new plan for this query. But if it does, it still needs to verify whether the existing plan in cache is valid. Now, an execution plan in cache can be invalid due to many reasons. If there was any change in the schema of the underlying tables or indexes since the plan was generated, the plan is invalid because either it cannot run because a column is missing, or maybe there is a new index and a new plan could be better than the existing one. So it is marked as invalid and a new plan has to be generated. Maybe statistics are not updated. There isn't updated statistics, and then again a new plan has to be generated to potentially generate a better plan. Maybe there are different set options. There are all kinds of reasons. We're not going to go into this in details right now, but there are all kinds of reasons why a plan might become invalid. And if the plan is invalid, then again, SQL Server has to go and recompile the plan for the same query, optimize the query, generate a new plan, compile it, and put it in the cache before it can execute it. So these are the steps, and I would like to show you a demo about plan caching. Here we go. So I'm going to create a view because I'm going to use it a lot, and this view selects from several DMVs. sysdm cache plans. This DMV returns all the entries in the plan cache, all the execution plans currently in cache, and I'm going to cross-apply to exec query plan and exec SQL text to retrieve the query text and the query plan for each query in cache. And I'm also going to join to dmexec query stats just to get the last execution time, so I can then sort everything by the last execution time. Okay, so this is the view. Let's look at the view. Okay, so this is what happens now in the plan cache in my laptop. It's not a production system. It's not very interesting, but there are a few things here. And I can see for each plan the query text, the plan itself. Okay, so I can choose something like this one and see the plan in cache. And the execution count, which is a very important number because, again, our goal for the plan cache is to be able to reuse plans. So I would like to see here high numbers. Okay, these are not high numbers, but again, this is my laptop. It's not very interesting. We have the object type. We're going to talk about this later, and the size of each plan in cache and the last execution time. Okay, so maybe there's a query plan with many execution counts, but I can see that the last execution time was a few weeks ago. It's not really interesting. Or maybe there's a query that has just run a few seconds ago, but the execution count is just one, so maybe it's just a one-time query. Okay, so we have to understand what we look at. So we have this statement, this is free pro cache to empty the plan cache, and if I run the view again, we can see that the plan cache is currently empty. Now, let's run our case study query. Okay, select all the customers from Israel. And I'm going to select from the view. I'm adding here a filter on the query text to just retrieve my query. Okay, and here it is. I got the query text. I can see the plan in cache, the same plan we've seen before. We see that the execution count is 1. This is an ad hoc query. It's not a procedure. It doesn't have parameters. It's an ad hoc query. And it was just executed, of course. I will execute the same query again, and I hope to get a reuse of the existing plan. And yes, we can see that the execution count is now 2. Okay, so great. We have a reuse of the plan because it's the same exact query with the same hash value. I'm going to execute it again, and I hope to see 3 execution counts. But oops, we get a new line with execution count of 1. Okay, and it's the same query, it's the same query plan, but it was recompiled. It was actually compiled again, and we have a different entry in the execution plan. And the reason is this. Okay, I intentionally put a space, a single space here in the query, whereas before I didn't. And just to show you that the way SQL Server looks for the plan for the query in cache is by calculating the hash value over the text of the query. So every single difference in the text of the query will generate a different hash value, and as far as SQL Server is concerned, this is a different query. It has to compile it and generate a plan, even if the resulting plan is the same plan, of course, in this case. Okay, now, of course, in reality, we don't run the same query with space, without space. Okay, this is not the case, but we do this. Okay, the same query, but now we're going to ask for the French customers, for example. And if we look at the cache, we have another ad hoc query with another plan. Okay, so now each time we run the query with a different value here, we will get a new compile and a new plan. And this is, in this example, we don't have too many values for the countries, but think about another query where you have a transaction ID, for example, or amount, or something that has potentially millions or even billions of different values. Okay, so you can potentially have millions or billions of compilations and execution plans ending up in memory, in cache, and this can bring your server down. Okay, because it's very CPU bound, the process of optimizing and generating a plan, and it works a lot with memory, and memory is going to be swamped with a lot of execution plans, identical execution plans on the account of different other things that might benefit from memory. So this is not very good for performance. Okay, so let's go back here. Yeah, there we go. Steve, do we have any questions so far?
No.
Okay, excellent. So I hope that means that everything is clear. Good. Now, I would like to show you 7 different ways to execute your query. Okay, and again, during the live presentation, this is where I play the song 50 Ways to Leave Your Lover by Paul Simon. I love Paul Simon. I love specifically this song. I'm not going to play this song, so you can sing it for yourself if you like, while I will continue the presentation. So just like Paul sings about 50 ways to leave your lover, I want to talk about 7 ways to execute your query. Back to the demo. Okay, so let me empty the plan cache again. So number 1, I call it non-parameterized T-SQL query, and it's what we've already seen before. Okay, so we have this query. Here it is in the cache. We've already seen that. And if I ask for the French customers, I get, of course, another different entry in cache with the same execution plan. Okay, this was number 1. Number 2, non-parameterized dynamic SQL query. So I have a local variable with a value of the country. Okay, and I have another one to have the statement, the query text. And then I dynamically build the statement text. I'm going to concatenate here the country. Okay, so eventually what is in the text is a static ad hoc query. Okay, just like the one we had here. All right, and then I'm going to execute this statement. Okay, this is dynamic SQL without parameters. Okay, and if we look in the cache, we're going to have another entry, okay, with yet the same execution plan. Now, you might ask why, if the resulting text is identical to this one, okay, if we look here, okay, this is IL, the resulting text should be the same, why don't I get the same plan, the reuse of the same plan? And this is because of the white spaces here, okay? If I would generate dynamically the dynamic text the exact same way with the exact same white spaces as the static text here, I would get the reuse of the existing plan, okay? And again, if all I change is the value here, which goes here, the text is different, we get a different hash value, we get another execution plan. Okay.
Yeah.
Still, we don't get a reuse. Yes.
One person just asked a question at this point. If you change anything in the comments, will that generate a new plan?
Yes, absolutely. If I run the old batch, including the comment, well, not this one, sorry, not this one, because the actual execution is of this text. Okay. But if we go here, for the static one, for example, okay, if I run this, and then I run it with a different comment, yes, it's part of the batch, it's part of the text, it gets a different hash value, and yes, it's a different plan. Okay?
Good deal.
So this was number 2. The third way to execute your query is a parameterized dynamic SQL query. So again, this is a dynamic SQL execution, but now I'm going to use sys sp execute SQL with parameters. So I'm going to have the country again, I'm going to have the query text again, and now I have another variable here called parameters, which will hold the parameter declaration. And this time, the query text contains the query, but I don't just concatenate the value. I hold an inner parameter of the dynamic execution. I called it p-country to be able to distinguish it from this local variable called country. So we have a parameter called p-country inside the dynamic batch. And I use the variable parameters to declare this parameter, this inner parameter, and then I dynamically execute the statement with parameters using this system store procedure. I pass it the statement itself, the parameters declaration, which is this one, and now for each parameter inside this declaration, I pass the actual value. So for the inner parameter P country, I'm going to pass the value that I hold in the local variable country, which is currently IL. Okay, so this is going to be a parameterized query. We get the same result, of course, the Israeli customers, and the same plan. But this time, look at the cache. We have a prepared execution plan. It's not an ad hoc, it's a prepared. And prepared actually means parameterized. Prepared is not a good word in this context. It's a parameterized batch or query. And we can also see in the batch text that we have first the declaration of the parameters contained within the statement, and then the statement itself with the parameters embedded inside. Okay, so this is a prepared statement using parameters. And of course, the whole idea here is that now all I need to change is the value of this local variable, and it goes here as a parameter, and we actually use the same parameterized query, and we should get a reuse of the same execution plan, okay, for the first time. So great. Okay, now we have a reuse. We can use any value we want in this parameter, any country we want, and we have a reuse of the same execution plan. So this is great. This was number 3. Number 4, let me show you how it is done from the application side. So I wrote a small, simple application, okay, using ADO.NET, and I'm going to start with a non-parameterized query. I'm going to show you the code in the application in a minute. Okay, let's start from the Israeli customers. And now, let's look at the cache again. Okay, so again, here is a new entry for the Israeli customer, the same query, but this time it comes from the application. And if I do fr, then of course, a lot of copy-paste here. Okay, we get another one because it's a non-parameterized. And now let's try IL with a parameterized query from the application. And here it is. It looks just the same as this one, okay? And it's actually the same thing behind the scenes. When I run the parameterized query from the application side, it actually calls the same sys sp execute SQL store procedure to run the dynamic batch. It's the same behavior. So if I'm going to do fr now with a parameterized query, you can close that now. Sorry. And look at the cache again. So we get a reuse again. Okay. Now here is the code in the application. So in the case of the non-parameterized query, I run this query and I concatenate the value in the text box, which is the country code. Okay. It's the same as I showed you before in T-SQL, generating a dynamic batch without parameters. And the parameterized option is also the same as I showed you in T-SQL. I have here the select statement with an inner parameter declaration, and in the code I declare the parameter as nchar size 2, and the value comes from the text box, and the direction is input. It's an input parameter. Okay, so it's the same idea. This is how it looks in the application code. We get the idea. And now, this was the 4th and the 5th ways to execute the query. The 6th way is, of course, a store procedure. This is classic. Okay, so I have a procedure, I have a country parameter, and then I have the select statement with the country, with the parameter embedded in the query. And I can execute the query, the store procedure, sorry, with the parameter IL. And in the cache now, we can see a new entry. This time it's proc. Okay, so we have a different object type for store procedure plans. Okay, in all cases, it's the same plan with the index seek. Okay, and of course, if we execute the same procedure again with a different parameter, the French customers, and we look in the cache, we will have a reuse of the store procedure. That's the idea of store procedures, right? So great, store procedure is also good. Now, the 7th and last way to execute your query is something I call looks like parameterized T-SQL query. Okay, and this is a common mistake that I see developers do. They declare a local variable, okay, called country with the value IL, and then I do this. Now, if we look just at the query here, it looks identical to the query inside the store procedure here. It looks just the same. And the reason is that we have this at quantity, the at sign. It's the same at sign for parameters and local variables. Okay, so this is a local variable that I declare here, while in the store procedure, this stands for a parameter of the store procedure. And even if it looks the same, it's a completely different thing. There's a completely different behavior between parameters and local variables, and I will show you that. If I run this batch, I get the same results, but look at the execution plan. This is the first time we get a clustered index scan. It's not a good plan for this. We have only 76 rows. It's not a good plan. And the reason is, look here, the estimated number of rows, okay, this is the number of rows the optimizer thought there will be in this query, 5555.56. Please remember this number. We'll get back to it later. The actual number of rows, we already know, was 76. And this is the reason that we got a plan involving a clustered index scan, sorry. Okay, and this is a poor plan. We got poor performance for this query. If we look in the cache, we can see that this is an ad hoc query. Even if you have the at country, it's not a parameter, it's a local variable, so it's an ad hoc query, which means if we're going to change it to FR, we have a different batch, a different ad hoc batch, and we have another entry in the execution plan. So we don't have a reuse of the plan, and we also suffer from poor performance by using the local variable, and I'm going to show you why in a second. All right, let's go back here. Any questions, Steve?
Yes, one was a little bit back. They wanted to detail, it was a new format for them, detail out the set parameters line, and
okay. This one?
I think that's it. Yes.
So what the question is?
They just wanted to understand it a little bit better. I guess, having the parameter within the parameter was a little different for them.
Okay. Well, when I use the sys execute SQL system store procedure, it has at least two parameters. One is the statement text, okay, which is this. And it has to include the inner parameter of the dynamic batch inside this one. And the second parameter of this store procedure is it's called params, and it has to include the declaration, the definition of the parameters, the inner parameters used inside the batch. In my case, I have only a single inner parameter, which is called p-country, and I have to declare it in a text like this: the name of the parameter and then the data type. Just the way I would declare the parameter in a store procedure. If I had multiple parameters, I would add here a comma and then the second parameter and so on. Okay, I hope that was clear.
I think he said yes. The other question that I've seen is the CPU time for compiling the execution plan the same for each of the methods of running the query?
Can you come again?
Is the CPU time for compiling the execution plan the same for each of the methods of running the query?
Oh, yeah. It doesn't matter if the query comes from an ad hoc query or from the application or whatever. As soon as you have to optimize, not you, the optimizer has to optimize and generate lane, it goes through the same methodology, the same steps to optimize the query, and the CPU cost is the same. But actually, there's a difference if it's an ad hoc query or a prepared. Okay, for a prepared statement, it goes through a different route to optimize the query, because it's a query that has to use a parameter and it can support different values. It's not an ad hoc value, so it's a different plan. It's a different process. But for each ad hoc query that comes from whatever, it's the same process, the same CPU cost. And for each prepared plan for the same query, we have the same CPU cost.
Okay. This person asked, so local variables within a stored proc are going to suffer as well. Do they need to be parameterized within a stored proc?
Oh, yes, absolutely. If you use local variables inside a store procedure and you use the local variables in a query, you're going to suffer from performance issues. I'm going to get to this later.
Okay. The last question, why wouldn't the app and T-SQL parameterized queries use the same cache plan? I know part of the answer to that, the settings, but I'll let you explain that.
Yeah, well, you might have different connections running the exact same query text, and yet they still get different plans. And one of the common reasons is the connections or the session set options. There are some set options like set ANSI null, set arita boards, that these options affect the way queries perform inside a session. Scope is the session. And if you have two different sessions with different set options that run the same query text, they will get different plans because potentially they can have different results for the same query, and a different plan might be optimal for each one. Okay, so this could happen. There's a classic problem when you troubleshoot a performance problem of a query that comes from a .NET application,
yeah,
and you copy the text of the query into Management Studio. You get a different plan because the default set option, the default arita board set option specifically, the value in the .NET is false by default, and the value in Management Studio is true by default. And you have now two sessions running the same query text, but they have different set options. You get a different plan. And in some cases, it's quite common actually. It happens to me a lot with clients. You want to troubleshoot a performance problem. You take the query. It runs for a long time from the application. You run it through Management Studio, get a different plan, which is excellent, okay? And then I tell the client, hey, everything is great. What do you want? Okay, so yeah, you're not looking at the same plan.
Yeah, that was the first time that we ever discovered that with the .NET code. It's like, it's great right here. And then we finally found where we could set it in our SSMS
Exactly.
to automatically be off, so we never had to run into that again. So
Right.
Let's see. What's the difference in ad hoc proc execution? I think you just went over that, but I'll ask it anyway.
Between ad hoc and proc?
Yes.
Well, ad hoc is a query that you run for just one time. Okay, you send it from the application. It's a query text without parameters. It's not a store procedure. It's just the text of the query. Okay, you tell SQL Server, please run this query. This is an ad hoc query. And proc is a store procedure, of course. So you have a store procedure in the server, and you just instruct SQL Server to execute the store procedure. It's a completely different thing.
I wanted to be sure they understood that before we went on. Okay, that's it.
Okay, excellent. So you go back to the presentation, and let's talk about a very important topic, which is called parameter sniffing. Okay, so yes, SQL Server sniffs the parameters. And actually, the idea is that the first time we execute a query, a parameterized query, or a store procedure for that matter, SQL Server sniffs the values. It knows the values of the parameters in that first execution, and it uses the values to compile the plan, to generate an execution plan that is optimal for this specific value. Now, local variables are not parameters. So when you have a query that involves local variables, you don't have parameter sniffing. And in compile time, when the optimizer generates the execution plan, it has no idea about the values of the local variables. So it treats these local variables as unknown values and generates a plan that is an average plan for an unknown value, which in most cases, or in many cases, this will be a poor plan. It won't be good for this specific value. Okay. Now the question is whether parameter sniffing is good or bad, because if we, for different values of the same parameter, we want to get the same plan, parameter sniffing is great, because in the first execution, SQL Server will use the parameter to generate a plan, and this plan will be reused for different values of the same parameter. But what if we run a query for the first time with the parameter value x, we get a plan based on x, we put it in cache, and then another user runs the same query with the parameter value y. And the parameter value y reuses the same plan, which is based on the value x, but now it's not a good plan for y. Maybe a different plan would have been better for the value y, but we're stuck with the same plan in cache because we want to have a reuse. So in some cases, parameter sniffing might be a bad thing, and this is how SQL Server behaves, and we need to see what we can do about it. Now think about it, parameter sniffing, to demonstrate the idea about parameter sniffing, because it's quite crazy if you come to think about it. Imagine you got a new job, Okay, you go to a factory, a production line, and your job is to pack the product goods. Okay, so whenever a product comes out of the production line, you need to pack it. You need to choose the best package for the product. They put you in a huge warehouse with lots of different packages of different sizes and shapes and colors, and they tell you whenever a product comes out of the production line, you need to choose the best package and pack it. And there is a very strange rule. Okay, and the rule is that the first time a product comes out of the line, you can choose any package you like. But from that point, you have to use the same exact package for all products that come along. Now, this is a big factory. They produce all kinds of goods. It can be a laptop, a basketball, a T-shirt, whatever. Okay, it's a strange rule, but you say, hey, what the heck? Okay, it's a new job. Let's try. Let's give it a try. And you want to be at your best. Okay, you come to the first day at your job, and the first product comes along, and it's a bunch of pencils. Okay, and you go and run and look for the perfect package for the pencils. It takes you a while, and you find the perfect package. Okay, you put the pencils in, and you're very happy. And now you have to use the same package for everything that comes along. So you bring a couple of packages with you, and you wait for the next product to come along, and the next product is again a bunch of pencils, and you're very happy. You have the same package, and you do it very fast right now because you already have the package near you. Okay, and then you wait for the third product to come along, and the third product is, oops, a tennis ball. And you have this package, and you have to use the same package because this is the rule. What do you do now? Okay, so for example, you can cut the tennis ball into pieces, but it's going to take a while, and it's not going to be very efficient. Okay, this is parameter sniffing. Okay, it's a strange behavior. You get a plan that is based on the first execution. Now, the first execution of a store procedure is just a matter of luck. It's a casino. Okay, the first time, let's say that you have a restart of the server. Okay, the application goes up, users connect, they start to work with the application. The first user that runs some report, okay, and uses some parameter, this user is going to dictate the execution plan that is going to be placed in cache, and it's going to be reused again and again for days or maybe even weeks ahead. Okay, it's quite crazy when you come to think about it. So let's see a demo about parameter sniffing. And I would like to show you how we can deal with it. Again, we empty the cache, the plain cache, and I would like to show you the statistics of the country index or the country column. Okay, so this is the histogram behind the scenes SQL Server has. Now, of course, for the sake of this demo, I created a very simple case study. So the distribution of values in the country column is very simple for the sake of this demo. Okay, so we have all kinds of countries, but we have China with 30,000 customers. We have UK, again, 30,000 more or less, and we have 40,000 in the US. And all other countries have around, I don't know, 70 customers per country, something like that. This is the distribution of the country column. This is the statistics, the histogram that SQL Server uses when optimizing queries involving the country column. And look at this value over here. This is the all density. This value, when you multiply this value by the number of rows in the table, you get the average number of values, the average number of rows per unique value in the table. Okay, so the average between all of these values. Okay, and I hope this number looks familiar. This is what we see when we use the local variable. Okay, because when we use a local variable, SQL Server doesn't know the value of the local variable, treats it as an unknown value, and the best thing it can do is it doesn't have to guess. It just goes to the statistics of the all density value and takes the average number of rows per value because it doesn't know which value it is. Okay, and this is why we got a clustered index scan instead of an index seek. Okay, so this is the statistics. And now let's demonstrate the problem. Okay, if I run the store procedure for the first time, and I mean the first time because I've just emptied the cache, so it's the first time we have to generate a plan for this store procedure with the parameter value IL. Okay, we get 76 rows, we get the index seek execution plan, which is good. Now another user comes and executes the same store procedure with the value US, which has 40,000 customers. So we get 40,000 rows now, but we have to reuse the same plan. This is how SQL Server behaves. And this is not a good plan at all. Okay, so if we look here, again, we can see that the estimated number of rows is 76 based on the Israeli customers, the IL value, and the actual number of rows in this specific execution is 40,000. There's a big difference there, and this is not a good query plan for this specific execution. We can also look at the properties of the select operator, and there's a property here called parameter list. Okay, and we can see here the parameter compiled value, which was IL, and the parameter runtime value in this specific execution, which is US, and this explains us the difference in the estimated and actual number of rows. Okay, so this is a problem, of course. Again, in this specific example, everything runs very fast, but in reality, in production, it can be very problematic for performance. And now let's see how we can handle this issue. So the first solution, a very simple one, is to execute sys-sp recompile and pass it the name of the store procedure. This system store procedure marks the plan of this procedure in cache as invalid. Okay. So remember when we talked about why would a plan in cache become invalid? This is one of them. We can manually mark a plan as invalid in cache, and this means that the next time someone executes this store procedure, it will recompile the plan for this procedure. Okay, so now let's assume the next time a user comes along and executes a store procedure with the value US, now we'll get a clustered index cat because this is the first time we have parameter sniffing again, and we compile the plan using the US value. But of course, we have the opposite problem now, because if another user comes and executes the procedure with the value IL, we still get a clustered index scan, while we only have 76 rows, and an index seek would have been better here in this case. Okay, so it's not a very good solution. It's like a free roll of the dice in the casino. Okay, let's have another chance. We might get lucky. Okay, but it's not a good solution. Solution number 2 is to use with recompile inside the store procedure. So when you add it with recompile inside the store procedure, like this instructs SQL Server to recompile the plan for this procedure again and again for each and every execution. In fact, it won't even put the plan in cache because there's no point. Okay, so it will just create a plan, run it, and throw it away. So the first time we use IL, we get an index seek. Next time we use US, we get a scan. We have the optimized plan for each execution, for each value, which is great. But of course, we pay in having to recompile the plan again and again. Now, this might be a great solution if this is a store procedure that is only executed once in a while. So the cost of recompiling again is not a big deal. Okay. Also, if the runtime, okay, the duration of executing the query is very long, let's say a few minutes. Okay. So the cost of recompiling is neglected, is nothing compared to the execution time. Okay, so it might be a good choice, but in other cases, in a very busy OLTP system where we execute the same store procedure maybe hundreds of times per second, and execution times are very short, adding the compile time for each execution might be very dangerous for performance. Okay, so it might be a good and very simple solution. It might be not, depending on your case. A slightly better solution would be to use option recompile at the query level. This is a query option. It goes with the query. Okay, it's not the same as with recompile at the procedure level. So we add option recompile, and two important differences between option recompile and the with recompile we've seen before. The first difference is that this is at the query level. So if we have a procedure with 20 different statements, a very long store procedure, okay, let's say we have 20 queries inside a procedure, and we only have a single statement that we want to optimize, it would be a waste to recompile the whole procedure each time, again and again. It would also be very expensive because it's a long store procedure. So we can only recompile the specific query that is problematic for us. Okay, this is one difference. The other difference is that option recompile happens at runtime, not at compile time. With recompile at the procedure level happens at compile time. Okay, this means that at runtime we have the store procedure. It is executed. Okay, we execute the first, the second, the third statement. When we get to the specific statement, okay, at runtime, SQL Server stops, recompiles only this specific query, generates a plan for it, runs it, and goes on with the original plan for the rest of the store procedure. And for example, if we had a local variable involved in this query, So we said that the local variable is unknown at compile time, but if we use option recompile, at runtime, the value is very well known, and SQL Server can use the value to generate a good plan for this query. So let's try this. In this case, we'll get the same behavior. We use it for IL, and we get an index SIC, and we use it with US, and we get the scan, of course. Sorry, ran this twice. So again, it's slightly better than alter procedure, but again, we have to pay the recompile in each and every execution, which might be very expensive for us. Another solution is to use optimize for. It's another query option, and it goes like this. Optimize for country equals some specific value. So I can decide based on which value of the parameter I would like SQL Server to optimize the query. Okay, so instead of having the casino effect and relying on whatever value the user uses in the first execution, okay, I want to decide, because I know that in most cases users use the US value. Okay, I don't want to take the risk that in the first execution someone will use the IL value, so I can say, regardless of the actual value in the first execution, when you optimize the query, please use the value US. Now, of course, the results will be the actual value that the user has used. It will be the Israeli customers, but the plan will be based on US. Okay, so if I do this, and the first execution happens to be IL, I will still get a clustered index scan based on the US value, but I get, of course, 76 rows, the Israeli customers. Okay, and of course now if I run it with US, I can reuse the same plan, which is great. So this is another option. Not optimal, but it can be good for some cases when I know that in 99% of the cases I use the same value, and I don't mind that in 1% of the cases users will get poor performance. I just want the 99 to ensure that they get the best performance for the query. Okay. The fifth and last solution is, it's the most complex solution, but it's the best. Okay, we get the best of all worlds. Is I create a table here. The table structure is similar to the histogram that SQL Server maintains for statistics. Okay, because I want to store the statistics in my user table. And now I'm going to insert the results of the statistics using this statement into my table. Let's create a table. Okay, so here it is. I have the histogram in my user table now. And now the idea here is to run some code, some kind of algorithm to distinguish between common values and uncommon values. Common values meaning many rows for the same country, which will result in a clustered index scan, and uncommon values are all the other countries that will result in index SIC. And in this case, what I do is I count the number of rows in the old table, and then I delete from my user table all the countries that have less than 1% of the rows. Okay, this would be uncommon countries in my case, and I leave only the common countries in the table, which turns out to be China, UK, and US. Okay, our common values. Now this is again a very simplified example for the sake of this demo. In reality, it might be quite complicated to come up with an algorithm that will distinguish between common and uncommon values very well. But it can be done. I've done it several times, and when it's done correctly, you can get great results. I will show you how. So now, when I have my table here with the common values, common countries, I'm going to create another store procedure, and I will add a suffix common, okay? And it will look the same as the original store procedure, okay? With the same query and the same parameter. And I'll create another store procedure called uncommon, okay? Again, with the same code and the same parameters. And now I will alter the original store procedure. This one, the procedure that the application executes. And what this procedure is going to do now, I will check in my common countries table whether the parameter that the user has passed is in the country, meaning whether it's a common country or not. And if it is, I'm going to execute the common store procedure with the same parameter. If it's not, I'm going to use the uncommon store procedure, which is the same code. Okay? And what will happen here is that the first time a common country comes along, I will execute this stop procedure. And in this stop procedure, we'll have parameter sniffing, and we will generate a plan based on a common country value, which is a clustered index scan. The first time an uncommon value comes along, we will execute this stop procedure. Again, parameter sniffing here, we will generate a plan with index seek. And every time a value comes along, it will go to the appropriate stop procedure and will reuse the same plan. Okay, so what we have here is the best of all worlds, because we only have to compile twice, only twice. Okay, and we can reuse the appropriate plan each time, whether it's common or uncommon. Okay, so this is the idea. Now, if I execute using IL, of course I get, this is the query that searches for in my user table. It's nothing, okay, in terms of performance. It has some overhead, but it's really small, okay, and this is the index seek I was looking for. And when I execute with US, we get the clustered index scan, and we have only 2 compiles. From now on, whatever I use, I'll get the right appropriate plan without having to recompile again. Okay, so these are 5 options. Let me just summarize that. Okay, so we can use sys sp recompile, just like a free roll of the dice in the casino. Let's try again and see if we get lucky. We can use re-recompile at the stop procedure level, and this will recompile in each execution. But it might be a great solution. If we have lots of executions, it might be problematic. We have option recompile at the query level, which happens at runtime and only recompiles the specific query. We have option optimize for, where we can decide based on which value SQL Server will optimize and generate a plan. And we have the multiple stop procedure solution, the last one, where we can distinguish between common and uncommon values and generate a plan only once for each group of values. Any questions, Steve?
Yes. Several people have asked if this exact code would possibly be available after the webinar. Is that possible, or since you're using a different database?
Oh yes, of course. I will again. I will publish everything in my blog, including the script to generate the database schema. The old example can be regenerated, reproduced. So yes.
Perfect. That'll make a lot of people happy, including me, because I wanted to run through this. I love the way you've kind of separated out each different type, and you've got the example to run with. Okay.
Great. Thank you.
This one's a little bit longer question, and it's a little bit was about 10 minutes ago. What's the difference in performance between a prepared proc object type and with the code first methodology and entity framework? As I understand, the .NET framework builds parameterized queries for you behind the scenes. What would be the relative performance difference in those parameterized queries and stored procedures?
Well, if you use entity framework or any ORM and you use parameters, yes, it will generate a parameterized query behind the scenes, and it would behave the same in terms of parameterization and reusing the plan for different values of the parameters. It's the same thing. The big difference between ORM and a stop procedure is that when you write a stop procedure, you have full control of the code. You write the query itself, and you can optimize it, and you can decide how to write it and add maybe query options and maybe different stuff. When you use ORM, not with a stop procedure, the code is generated for you. And from my experience, in many cases, yes, it will generate a parameterized query, but the query itself not necessarily will be an optimized query, and you don't have the control over the code to be able to troubleshoot it and maybe rewrite it or do other magic with it.
Okay.
I hope this answers the question.
Hopefully that did. He hasn't responded. Can you also assign the parameters to local variables to get around parameter sniffing?
Yes, and maybe we should get to the next topic. We don't have much time.
Okay, go ahead.
And I'll demonstrate. Okay.
And since you're going to show your blog and everything, there's quite a few questions building up now. Hopefully, I can send you the questions after the fact, and maybe you can blog about the answers.
Sure, absolutely. That would be great. Yeah. Okay, so I would like to talk about a very common behavior, a very common mistake that I see developers do, and this is changing the parameter values. So you have a store procedure, you have parameters, and then you change the values of the parameters inside the store procedure code, and then you use the parameter inside some query. And the problem is that at runtime, the query now uses the revised value after the change, while the plan is used with is generated based on the value before the change, because it sniffs the parameter value at compile time before this procedure is even executed. Okay, so I would like to demonstrate this, and this will also demonstrate the problem with the local variables. Okay, so no, sorry. No. Okay, sorry about that. So empty the cache. I'm going to use a different store procedure for a change. It's called customers by last purchase date. This store procedure has a date parameter with a default value of null. And then inside the store procedure, I check if the date is null, I'm going to change it to last month, okay, 1 month ago. And the story behind this case study is that we have reports in the application, and there's a date picker, a date control in the report, and users can choose the date and then execute the report, and the report will return all the customer that had a purchase after a certain date. Okay, so you can see here. And at some point, the users complain and say, we usually, in 90% of the times, we want to look at the last month. Okay, so don't let us have to choose the specific dates 1 month ago. Please have the default behavior of the report screen to use the last month. Okay, and this is the solution. Okay, so the developer added a default value here, and if the user doesn't choose anything, okay, it just passes the null value, and the developer then changes it to 1 month ago and returns the last month. Okay, I see this a lot. It looks okay. Let's just add an index on the last purchase date. Okay, let's run it once with a specific value. Okay, it's October 1st. We get a clustered index scan. We get the right number of rows as an estimate. Yeah, whatever. Okay. Now I will put recompile here so that I can have a new plan. And this time I use the default value of the parameter. I don't pass any value for the parameter. It will use the null value. And I will get the last month, okay, 8,200 and something customers who had purchases in the last month. But we get an index sick now. And you can see here that the estimate number of rows is only 1. Well, the actual number of rows is 8,000. And the reason it's only 1 is that the plan is based on the null value, which was passed into the store procedure. Parameter sniffing uses the values that is passed to the store procedure and not the actual value at runtime after the change. Of course, this is a problem. Okay, so we can try to handle it by avoiding the change and just putting the expression is null with the date add and everything inside the query. Okay, so we don't change the parameter, we just use an expression here. And if we do that, again, we use the same default value. Okay, we get a scan, which is good, but this is just a matter of luck, because the estimate number of rows is now 30,000 and not 8,000. And the number here, 30,000, is because this is actually an unknown value for SQL Server. It's compile time. Okay, because of the is null, SQL Server doesn't know the actual value. It can change each time whether it's null or not. Okay, so it treats this as an unknown value, and it uses the same algorithm for unknown values. In this case, this is an inequality, and the optimizer uses a rule saying I will estimate 30% of the table. The table has 100,000 rows. It estimates 30,000 rows just because it's an inequality with an unknown value. Okay, so it doesn't have a clue about what's going on here. It doesn't help. And we can do another thing. Instead of, like someone asked, instead of using the parameter and changing the value, we can declare a local variable, and this local variable will have the value after this expression, and then we can use the local variable inside the query. And again, since this is a local variable, we're actually disabling parameter sniffing here, and local variable is unknown at compile time, and we get the same behavior of 30,000 rows. Okay, so this is not good either. We can use option recompile. Okay, now option recompile again happens at runtime. So at runtime, we're going to recompile this with the actual value. Okay, after the change, which is good. So this is going to work. Now we can see that we have a clustered index scan, and the estimated number of rows is correct. Okay, but again, the price here that we have to pay is to recompile in each execution. Another thing we can do, we can create an inner store procedure, a different one, okay, with the parameter date, without changing it, and alter the original store procedure, okay, where we change the value, and then instead of running it, we only execute the other store procedure. Now the other store procedure will have parameter sniffing with the actual value after the change, and this is another way to solve the problem. Okay, so we get it, sorry, here with the actual value. Okay, so again, this is very common. I see that a lot, and actually the best solution here would be to change it in the application code. Okay, so let the application do anything it needs to do, any calculations, and pass the actual value to the store procedure, and the store procedure just need to execute the query. This would be the best solution, but in many cases we can't change the application for all kinds of reasons, and we have to do our magic inside the store procedure. I think we're running a little bit late, right?
Yes, that's okay. Or I'll let you finish, and then we'll answer or ask one question or two then.
Okay, so just a few slides. I don't know if we have time for the demo for the last topic, but at least to cover the topic itself. SQL Server has a property called parameterization. Parameterization can be either simple or forced. In simple parameterization, SQL Server will automatically parameterize some queries, only very simple queries. When you have a very simple query for which it doesn't matter which value you use, SQL Server will choose the same execution plan. SQL Server will go and parameterize this query for you without asking you. And this is a good thing, because otherwise it will have to regenerate the same plan again and again and again. It will be a waste of resources. So it will do it for us, which is great. We can also choose to use forced parameterization, which means for each and every query, regardless of whether it's simple or complicated or whatever, SQL Server will force parameterization, in most cases actually, because there are some limitations. Now this could be a good thing, this could be a very bad thing in some cases. We have to be careful here. We can apply parameterization either at a database level. There's a database property called parameterization, simple or forced. We can also do this at the query template level. Okay, we can instruct SQL Server to force parameterization, parameterize a specific query of a specific template, regardless of the values of the parameters, of course, and it will do it for this specific query. Okay, so it's more complicated to handle it, but it will be safer to just fine-tune a specific query rather than change it for the whole database altogether. Now, do you think we have time for a demo? Or I'll just leave it for the script that people can use later.
Sure, go ahead and do it, and since it's recorded anyway, I'll include it in the recording. So.
Okay, excellent. So I'll try to do it quickly. So if we use the same queries before, okay, with the country, okay, this is, we already seen that this is an ad hoc query, okay, we've seen that before. I can see in the plain case that it's ad hoc. But look at this. I'm running a slightly different query. I'm querying on the ID. Okay, I'm looking for the customer ID 1234. The ID is primary key, and it also has a clustered index on it. And this is an ad hoc query, of course. I'm using an ad hoc value, a constant value. But if we look at the query plan, at the plain cache, sorry, we see a prepared statement. So SQL Server automatically parameterized this query for me without asking me. And the reason is that in this specific case, it doesn't matter what value I put here, it will always produce the same query plan, which is the index C. Because this is a primary key, it will always produce a single row, regardless of value, either 0 or 1 row. okay? And since there's a clustered index, it will have a clustered index key, so SIG, sorry. So now I can use, I don't have to change anything in the application. SQL Server will do it for me, okay? It will reuse the same query template, which is great. At the database level, we have in CS databases a column called is parameterized forced, which is currently 0, which means it's in the simple parameterization mode. I can change it to forced with the alter database set parameterization forced statement. Now it's forced. And now, if I use the same country query and I look at the cache, so even for this query, we have parameterization. And we already know that this can be dangerous in this case, because if we use different values, either US or IL, we want to get different plan. When it's automatically parameterized, we will use the same query plan from the cache. Okay, let's go back to simple. Now there's a code here. I'm not going to get into details now. Really late, okay, but you'll get the scripts later. There's a code here to create a plan guide to force parameterization for a specific query template, which is this one. Okay, so this is how I can instruct SQL Server to, under the simple parameterization at the database level, still I can force parameterization for specific query templates. Okay, so I'm not going to show this. Okay, this is the demo for this one. And just to summarize, okay, so I hope I convinced you that parameterization is a very important topic in SQL Server when you do performance tuning or even when you develop your stored procedures or applications. You have to understand how to use parameters correctly, and if you don't do it correctly, it can and usually it does lead to poor performance. I see that a lot with our clients. And just to take away the tips from this session, so in most cases, usually distribution is more or less uniform, and this means we want to have parameter sniffing and we want to reuse the plans in cache, and this means that we want to use parameterized queries. Always prefer, well, almost always prefer to use parameterized queries. When it's not uniformly distributed, okay, so you need to rewrite your code and to handle this with the methods that we show in this session. Avoid local variables, okay? Don't be tempted to think that a local variable behaves like a parameter, even if it looks the same. A local variable is unknown at compile time, and it's very dangerous for performance, so avoid the use of local variables in queries. Okay, and don't change the parameter values inside stored procedures. So either use option recompile or use an inner stored procedure to pass the actual value at runtime after the change. And you can use force parameterization, but you have to be very careful about it because it can hurt performance more than it helps performance. When you can, do it at the query template level, and even if you do, you have to test it in a test environment and make sure that it actually improves performance and doesn't do the opposite. Okay, it can be very dangerous. And that's just to get back to the story. So again, the client, the thing that happens, and it happens once in a while, there is an auto-update statistics at the database level. And at some point in time, even though the customer didn't do anything, there was an update of statistics automatically. And since there was an auto-statistics update, the relevant execution plans that relied on these statistics were marked invalid, and the next execution generated a different plan, and then we have the casino effect. Okay, so we have a plan of a stored procedure running for 50 milliseconds each time because it had reused the plan in cache, and now because we generate a new one, and in that specific execution, a user executed the stored procedure with an uncommon value, which created a different plan that runs for 5 seconds each time, and now we're stuck with this plan. Okay, so you already know what to do in this case, and I do it many times with clients, and it happens once in a while. And when I tell the clients and I explain why it happens, in many cases they get frustrated, and I can really understand them because it's quite of a weird behavior. Okay? You don't expect things to happen like that without any change made on your side. Okay, suddenly another plan comes along, and it's a bad plan, and it's not just one time. Okay, from that moment until the next time there is a change in the plan, you are stuck with a poor plan. Okay, this is how it goes. Again, I will publish everything, the presentation and the scripts, and I think you need to reproduce these demos in my blog. I also want to point you to a series of blog posts I wrote about parameterization, which more or less cover the same topics that I have here. Okay, so you have the link here. And if there are questions, and if there is time, that I would love to answer them.
Okay, well let's go over a few of them. We don't have time for all of them. The last 15 minutes generated tons of questions.
Okay.
The option is not more expensive than okay, so they're finding. Okay, is there a way to find stored procs that are using index scans and seeks? Can you look at histograms, or do you troubleshoot as issues arise? He's wanting to pre-find this stuff before it causes problems.
So he is asking if we can look at the plan cache and look if we already have plans involved with seeks or scans, something like that.
Yes. That I think.
Well, you can query the plan cache using the DMVs I showed before. Either it's exec cache plans or query stats, and you can cross-apply to the I think it's called exec query plan. You get the show plan XML. And then you can use your xquery magic. You can write xquery queries to manipulate, to extract values from the query plans, and you can look for operators that are named clustered index scan or index seek or stuff like that. If you don't know xquery, you can Google it, and you can find all kinds of scripts on the internet doing that. And you can actually query the entire plan cache and look for for example, all the plans involved in the clustered index scan. Okay, it's quite easy to do that once you get a hold of it. So yes, you can, of course.
Okay, just along those lines, Glenn Berry has some excellent scripts that are updated for each version all the time, and he's got some specifically
right.
at that. He's got some great ones. Let's see. Question the option multiple stocks numbers. Can you use the query hash to determine the most frequently used query instead of the statistics?
Yes, absolutely. You have in sysdm query stats in this DMV, you have the query hash. This is one of the columns there, and you can group by the query hash and look for the number of occurrences in cache. And yes, this is another way to look for the most running queries.
Okay, this user, and they're still here, can you please explain the difference between with recompile and option recompile?
Yes, sure. With recompile happens at the procedure level, which means that the whole procedure is recompiled every time. Option recompile is part of the statement, the specific query, which means only this specific query will be recompiled each time. So if a stop procedure has many, many statements, only this one will recompile. And another difference, which is very important, with recompile, instruct SQL Server to compile the stop procedure at compile time, meaning before execution begins. And option recompile instructs SQL Server to recompile the query at runtime during the execution of the stop procedure. And this means that if there are any change of parameter values or local variables defined and set and everything like that at runtime, the plan will be generated based on this information.
Okay, that's about all the time we have for on that. I've got a couple of minutes myself, and people have already started leaving to go to lunch. And anyway, thanks for a fantastic presentation. And as Guy stated, his stuff is up there. You can go find it at his blog, hit his podcast up. And I'm sorry I wasn't scheduled to do this webinar, and I didn't even realize that you were in charge of a chapter. If you got the Israeli chapter, if you got any sessions coming up, you can go ahead and say something about that if you want to right now.
Yeah, we have a session each month. We have a meeting in the local chapter in Israel each month. The next one is March 7th, the next Monday, actually. We have a session about the big data roadmap of Microsoft in Azure, and we have another session about the new feature in SQL Server 2016, stretch database. So it's going to be very interesting. Sometimes we have those meetings recorded, not always. And yeah, we have a very strong and large community here in Israel, so it's great.
Okay. We have been, for the first part of the year, instead of giving away money each, a prize, a door prize each session, we're accumulating January, February, March, since we have two groups that we give that gives presentations. Our $300 that we would have been able to give out spread across January, February, March. This would be the last session we'll give in the U.S., and the one that's being given next week on March the 8th, you'll be included, whoever shows up will be included in a drawing. One person will get a $300 Amazon gift card. So, and that's the transaction log and how it affects HADR. Also, one session I didn't talk about was be a role model for women in tech through blogging. That's with one of our favorite speakers, Mickey Stewie. That's with the Women in Technology virtual chapter, and that's going to be the 21st of March. And with our sponsor. Somebody asked about bringing that screen back up again, but basically if you go to a very easy website to remember is SQLperformance.com, and you can find everything from that, or SQLcentury.com. And next month will be Aaron Stellato with Kicking and Screaming, going to extended events. And I think we're going to sign off. I really appreciate everybody showing up. Sorry I've been a little disorganized today, but Guy did a great job. So thank you.
Thank you very much.
That was good. I really, I was looking at those scripts and I was saying, hey, I've read a lot about this stuff, but this is good. You've got them in there. Each one as you go along, each of the different solutions. We ran into some problems in the winter, and it turned out that we fixed it with updating the stats on just a couple of indexes at a certain point in time because the tables were so large.
Yeah.
And we had something very similar to that. We had some parameters that were getting changed by different parts of it. We have web transactions that come through all night, and it was changing that particular stored procedures execution plan for all of the rush of people in the morning, and that stored proc was timing out constantly. So we had to come up with some different ways. We didn't want to, it really redoing the stored proc was not the best solution in this case. The statistics was. So anyway,
Yeah.
that's why this stuff was just right on my mind, and I think it was right on Neeraj's mind too. And he said that you had a great presentation. Here, I'll turn him back on.
Well, thank you.
It passed, so. Okay, here's Neeraj if he wants to talk. So.
Neeraj, are you there?
Yeah, this was like, I think I told you, like we had the similar issue, and the statistics really helped in that one, because every morning the store prog was getting timeout, and we were thinking like, is there any parameter sniffing happening or something like that? So the presentation you had given in SQL Pass definitely